Mathematics, love it, leave it. Welcome back to our math session. Today we are going to have a look at how we move from inequalities to graphing in details. Because we could be given more than one inequality to be graphed on the same graph. That's what we are having a look at today. Let's go. Here we are. What we are on the same graph. Show these regions. The regions are, the first region is y is less than or equal to 2x plus 4. That's the first region. Then the second region, b, x plus y is less than 6. The third region is c, which is y, is greater than negative 2. Therefore, this is the task we have. And if that's the task we have to improvise ways of how we can simplify our going, our smooth moving on. Remember from the previous session that these inequalities can be expressed in a different way. And now, when we come to graphing, it means that it's better if we come out with a table of this nature, summarized information. Then in our table, we shall have columns. The column for inequality, because what we've been given here are all these ones are all inequalities. Then secondly, we have to talk about the boundary line, because in a graphing we have to think about the boundary line. Then on top of that, we have to think about the nature. And remember that the nature can be determined by the inequality sign that's in the original, what has been given us. Then after that, we look at the points or the cuts. When we begin off straight away, let us move with the first inequality, which is y is less than or equal to 2x plus 4. We say that when the inequality is either less than or equal, greater than or equal, the nature of that boundary line has to be solid. Therefore, here the nature is solid. The nature here is solid. That's the nature. Then, when we come to this one, the second one, which is x plus y is less than 6, we said if we have this or that means that the nature of the boundary line has to be broken. Therefore, the nature here is broken. Likewise here, it is greater than. Also, the nature is broken. Then you have seen that. We said again that when we want to have a look at the boundary line, what do we do to get the boundary line? The boundary line, every sign which is put there, either this sign, or that sign, or this sign, or that sign, all of them are replaced with equal signs. Equal signs. Therefore, for this one, it's going to be replaced with equal signs. This one will be replaced with equal signs, and this one will be replaced by equal signs. Therefore, the boundary line here is going to be y. Is going to be y equals, where are we getting equals from? Because we said that all these signs are replaced by equal signs. Then we have 2x plus 4. So now here the boundary line is y equals 2x plus 4. Where are we getting it from? Because we've also agreed previously that this one is replaced with equal signs. So now we are having y equals 2x plus 4. Right? Let's go. Then here, the boundary line here is going to be x, y, plus y, alright, equals 6. Here we are having x plus y equals 6. This sign has been replaced with equal signs. Now we come to this one again. We are having y equals negative 2. Y equals negative 2. Then after that, this column is complete. This column is complete. How have we got the nature? By depending on this. This is greater than, this is less than or equal, it is solid. This is less than, it is broken. This is greater than, also it is broken. The nature of these signs are replaced with equal signs. That's how we are. Next, we come to the points or cuts. Points or cuts. Now take note of this. Be very more critical with this. If at all you happen to see that we have the x and y in any of the inequalities, if we have both of them x and y, we use the cuts method. I'm repeating. If in the expression we have x and y, that means that we qualify to use what we call the cuts method. Cuts method, we are looking at the points where that line cuts the x and then the y-axis. Cutting, that is crossing. Then, when you have only either x or y, when in the expression or the inequality that has been given to you only has x and y, don't use cuts method, but we resort to points. Now here we have x and y. What are we going to use? We are going to use cuts method. Here we have x and y. What are we going to use? Cuts method. Here we have only y. What are we going to use? We are not going to use cuts method, but we are going to resort to points. Let's go. So now here we are. When it comes to this one, y equals 2x plus 4. 2x plus 4. We are going to say somewhere that when x equals to 0, when x equals to 0, I believe that you have side one, where you can calculate out this one. When x equals to 0, we substitute into this and say that now our y is going to be 2x plus 4. When x equals to 0, so we are going to have y equals 2 times 0, 0 plus 4. Then that means that our y is going to be 4. Now when x equals 0, y equals 4. Y equals 4. Now what's that? That is the first cut. The first cut is going to be 0, 4. How have we got that? We foresee that we are using cuts method. That when x equals to 0, we go back to our boundary line and substituting. Where there is x, we put there 0. Is it okay? Then after that we are saying y equals to 2 times 0 plus 4. And now multiplied by 0, you get 0. So the first cut is when x is 0, y is 4. Then next we say when y equals 0. When y equals 0, again we go back to our same y. When y equals to 0. When y equals to 0, we are having this one again. That y equals to 2x plus 4. But remember that we've said that when y equals to 0, therefore we are going to put here 0. We are going to say 0 equals to 2x plus 4. 2x plus 4. This 4, all this one is going to come this side. And so we are going to have negative 2x equals to 4. Therefore, our x is going to be, when divided by negative 2, divided by negative 2. Our x is going to be negative 2. Therefore, the second card is going to be, this one equals negative 2. Now the second card is going to be, remember, when we are writing coordinates, we're beginning the x. Therefore, it is negative 2, 0. Negative 2, 0. Now, here the cards we've got, the first card is 0, 4, and the second card is negative 2, 0. Let's go. Now, that one is finished. This one is finished. Let us come to this one. This one is telling us that x plus y equals 6. Don't forget, we've said that when we have the x and y in the expression, always what we have to use, Katz method. So here we have x and y. We are also going to follow the same trend as we followed here. We are going to say when x equals to 0. When x equals to 0. When x equals to 0, we are going to bring this one. Don't forget that now this one has been worked upon. Now we are coming to this one. So we are having x plus y equals 6. When x is 0, this means that 0 plus y equals to 6. Therefore, your y equals to 6. Therefore, when x is 0, y equals to 6. Now the first cut is 0, 6. The first cut is 0, 6. Then we go to the second cut. When y equals 0. When y equals to 0. Don't forget outside one, where you can work out from. Now, when y equals to 0, we bring this one again. And say that x plus y equals to 6. But remember that this time, what is 0? It's being equal to replacing. 0 is replacing y. Therefore, we are having x plus 0 equals to 6. Therefore, our x equals to 6. Now the second cut is going to be this x equals to 6. Now the second cut is going to be 6, 0. The first one was 0, 6. The second one is 6, 0. Don't forget we begin with x and end with y. When we are in coordinate geometry, then here we are. We are moving to y equals negative 2. Y equals to negative 2. Here we have only y. Even if we had only x here, it means that we do not use Katz method. But what we use is the points. Now we have to state any point. So long as its value, the value of y is negative 2. We can say 0, negative 2. This is x, this is y. Then we can say 2, negative 2. I will retry 2, negative 2. Because the negative 2 is a constant, it's not a value. What is changing is only x. Then after that, we can also have negative 4, negative 2. Negative 4, negative 2. Now, having summarized all this information in our table, now the second task is to go to the graph. I hope now you can remember how we can get appropriate scale. We get the scale on the graph according to the values we have. The highest value of x we have here is 6. And then the highest value of y, 6. And also we have the negatives down in this one. So now, what are we going to do? We are going to graph. Now this is our graph. Our graph, this is the y-axis, this is the x-axis. This is 0. Even if we don't indicate that 0, 0, automatically it's known that it is 0. It can be called point 0, 0, or can be called the reference point. They mean the same. Then here, this is 2, this is 4, this is 6, this is 8. What does it mean? It means that if this is 2, then this is 1. This is 3, this is 5. Likewise, that side. Now you imagine that when it comes to graphing here, we have to consider each inequality given to us at a time. Consider it at a time. Don't worry and don't hurry. At a time. Now, if we have considered it at a time, what we do is simple. Imagine that you are climbing, or you've been told to climb from down the floor up to the roof. Now, when you are climbing down, where do you begin from? Do you begin from where you began off or from where you've ended? Automatically, the answer is with you. We begin off from up. Therefore, we are going to consider this row. This is a row. These are columns. Now we are going to consider this row. Why are we considering this row? We began from y less than or equal to 2x plus 4. Then we come to the boundary line, which is y equals 2x plus 4. Then we come to the nature of the line, which is solid. Then we have the cuts. Therefore, this means that now we are moving from here to this, to this, to this, and then we test. Now let's go. We have 0, 4. 0, 4 is here. Wow, that is our 0, 4, the first cut. Then the second cut is negative 2, 0. This is negative 2, 0. Negative 2, 0 is here. We began from here, now we are moving this side. We have 0, 4 is here, and then negative 2, 0 is here. Then after that, we have to join these points with a line. What will be the nature of the line? It's going to be solid. So we get our ruler and join this line. We are joining. We have to join. I hope you are seeing how best it is. Then joining. We've done the joining, not so? Then after joining, the line we've joined or the line we've used to join the points has to be given a name, and the name is this one. The name is y equals 2x plus 4. What have we done, or what are we doing? We are moving from here to this one, and then this. Though in the beginning, began from here to this one, to this one, to this one. You equate this one to climbing a ladder from bottom and going up. And when it comes time for you to come down, you begin from where you ended and come down. This is 0, 4, 0, 4 is here. Then negative 2, 0, negative 2, 0 is here. Those are the cuts. This is the y-intercept. This is the x-intercept. Then after that, we join them with a good line. Use a long ruler. Then after that, the nature of the line, it is solid. Then after that, what's the name? The name of the line is this one. Don't use this inequality. The name of the line is the boundary line. This one. Then after that, we have to test. We have to test which of these regions do agree with this. We've said that if at all point 0, 0 doesn't lie on the line, use that point 0, 0 to ascertain whether one of the regions agrees with this. And we say that if at all you get the answer when it is yes, that is the wanted region. When you get the answer when it is no, it is the unwanted region. But remember, we said that we could have shaded the wanted region. But due to the fact that the wanted region has some characteristics we have to analyze later on, we shade the unwanted. Now, let us use the test point as 0, 0. Test point as 0, 0. We are going to say is, we have this, y less or equal 2x plus 4. Now, if we use point 0, 0, point 0, 0 is becoming our test point. Now, where we have y, we put there 0. Where we have x, we put there 0. So we have 0. This is 1. Less or equal to 2 times 0 is 0. Then plus 4. Then we have 0 is less than 4. 0 is less than 4. 0 is less than 4. Is it true or it's not true? In reality, 0 is less than 4. Therefore, this means that this test point is acting as a sample. That means that all points that are lying down on this side of the line, this line, they all agree that it is less than that. Therefore, what we have to shade, we shade the upper part. When this one gets a 0, or when this one gets a yes, it means that the other side is no. Therefore, when we are shading, we don't shade it like in art. We use these ones. You can use your ruler. You shade, you shade, you shade, you shade. Then after that, we shall say, wow, The first region, this one has been shown. Then 2, we are moving to the second one. The second one also we are moving from this side. We have 0, 6, 0, 6. 0, 6 is this one. That is 0, 6. Then we come to 6, 0. 6, 0 is this one. Those are the curves. Then after that, we have to join them with a line. What's the nature of the line? Broken. Wow. Yeah? Yeah? Right. Broken line. This is the broken line. Wow. Broken line. It's a broken line. Broken line. Broken line. Broken line. The line is broken. Then having noticed that the line is broken, now we also give it a name. Where we get the name from here, which is x plus y equals 6. X plus y equals 6. Remember, when we are naming the boundary line, we don't use the inequality sign. We use the equal signs. Then still again, we have to test. Now, you totally forget about this one because this one is already done. Now the new phase is this one. Imagine that, first of all, this one was eating food. Now where we are referring to again, we are having something to drink. You don't say that I'm not drinking because I eaten food. You ate, but you never drank. Now this side, we are considering this line. Now this line also is divided with this graph into 2 parts. We have the region above and region below. We are lucky that again 0, 0 is not lying on the line. Let us use 0, 0 again. When we use 0, 0 again, we are going again to ask ourselves. Asking ourselves, is x plus y less than 6? X plus y less than 6. Now if we use our point 0, 0, using our point 0, 0, side 1, that is side 1. Using our point 0, 0, therefore we are going to say 0 plus 0, is it less than 6? 0 plus 0 is 0. Automatically 0 is less than 6. Therefore this means that this region also agrees with this inequality. Therefore, when this region agrees with this inequality, we say that by the moment you get the answer when it is yes, automatically that's an indicator that is the wanted region. Therefore, we shade the other region. So we are shading this. We are shading this. Are you seeing how we are shading? Alright. We are done. Now what are we remaining with? We are remaining with only one inequality. This one. We are beginning with this. 0, negative 2. 0, negative 2. 0, negative 2 is here. Then we have 2, negative 2. 2, negative 2 is here. Then we have negative 4, negative 2. Negative 4, negative 2. What does this one tell us? We are seeing that all these points are lying on this horizontal line. Therefore, let us do not hesitate. Let us join these points with a line. What's the nature of the line? It's going to be broken. So now, we do this. I see the indicator. This has been the indication that it is going this side. Therefore, we are joining. When we join, we are doing like this. There, it's broken. It's broken. Don't forget, it's broken. It's broken. 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 It's broken. Now, since it's broken, don't forget, having witnessed that it's broken, we have to give it the name. The name is y equals negative 2. Y equals negative 2. Now, if y equals negative 2, again, don't forget, these ones are already done with. So we are now, our point of concentration is along this line. Also, this line has divided the graph into two parts. We have the point from here upwards, and then the point from here downwards. Now, we have those ones that are greater than -2. So if at all we move along the y-axis, which values along the y-axis are greater than 2? Are they above the line going upwards or coming downwards? If at all we have to use some sense here, this is -2, this is -4. -2 is greater than -4. One may say that how can -2 be greater than -4? Now you just imagine if we are in terms of depth of the two, who is more happier? If you are in a pit with a depth of -4, with a depth of over 4 feet, and one is in a pit with a depth of 2 feet, who is happier? Automatically this one. Therefore, all numbers that are below this line, they are less than. And all numbers that are above this line, they are greater than. Therefore, we are going to show this one. We show this one. Therefore, we are showing this. We are showing that. Now, by the moment we have that, what have we done? We have shown all the 3 regions on the same graph. Therefore, we have this one shaded, this one shaded, this one shaded. So we are meaning with a region which is unshaded here. When it comes to further studies, we shall call this one the feasible region. So now, thank you for listening so much. What I need you to do is, there are some try numbers I'm going to leave you with that will try. Now the try numbers are here. It's only one try number, but in the very format of what we have been doing. So now the numbers are here. The numbers are here. It's going to be on the same graph. Show the regions. The first region is region A, which is x plus x. Now, the first region is x is less than or equal to 6. Then the second region is B. The second region is x minus y is greater than 0. Then the third region, C, is 2x plus 3y is greater than 6. Don't forget, this is the triangle. That's the triangle. Now I believe that with that bit we've shared with you, at least you can handle number. Now please don't forget, if this video has been helpful to you, please transfer that knowledge you've learned to others. But don't forget, like the video, and don't forget to subscribe. I love you so much. With mathematics, you love it and live it. God bless you.